So we're going to talk about the slope of a line. Let me zoom in here just a little bit. So slope measures the steepness or the slant or tilt. And the slope formula is equal to m, which is rise over run. So think about the fact that if you're sitting in a chair, you have to get out of the chair and rise before you can run across the room. So rise over run. And the rise is your change in the y, the up and down part, the y axis. And the running is the back and forth over the change in x. So we're going to do the change in y over the change of x. So that's where you're going to take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that'll be your formula. So graphs with different types of slopes. You can have one that rises, one that falls. You can have a vertical line, which is where you get a problem that is divided by 0, which is undefined. And then you can have a horizontal slope, which is a slope of 0. So there's a little guy called Slope Man. You can think about that. He's got a rise, a fall, got a little V here for the vertical, and then 0 slope is going to be your horizontal line. So let's go find some slopes. So for example 1, we are going to find the slope of a line containing the points. So for example 1, we have the point of 4, 0 and negative 2, 3. Remember that our formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the first thing I suggest you do is to label your points. It does not matter which one is the first point and which one is the second point. I've had students pull the same number twice, so if you label it, you'll less likely to make a mistake there. So we'll have m is equal to y sub 2, 3 minus y sub 1, which is 0, over x sub 2 minus x sub 1. And we'll end up with 3 minus 0 is 3. Negative 2 minus 4, they're the same signs. We'll add and keep the sign. That's going to get us negative 6. You always have to reduce. Both will divide by 3, so we'll end up with 1/2. It does not matter where you put the negative. You can put it at the bottom, out front, or at the top. It just doesn't matter. But that would be your slope, is negative 1/2. Now to show you, it doesn't matter which point we do. If we switch it around, we could do m. If we do this as the second point, we can do, the second, and that one is the first. We would get 0 minus 3 over 4 minus negative 2. Well, that double negative would be positive. We would end up with negative 3 over positive 6. It still equals negative 1/2. So it doesn't matter which one is the first point or the second point, because I had this one as the first point, second point here. Over here I had this is the first point, that is the second point. I'm going to get the same answer. So that's where it just doesn't matter as long as you're going the same direction as far as first and second. So, all right, let's go look at example 2. So for example 2, go up just a little bit here, we are going to use the points 5, negative 4 and negative 3, 3. So again, x1, y1, x2, y2. M will be equal to 3 minus the negative 4 over negative 3 minus 5. Again, double negatives make it a positive. So 3 plus 4 will get us 7. Negative 3 minus 5, negative 8. So that would be your answer for example 2. All right, let's go look at the slope of horizontal and vertical lines. So horizontal and vertical lines. So for example 6, that would not be example 6, this would be example 3, so sorry, my notes I need to update. If I have x is equal to -5, we need to understand that's a vertical line, it's an x equals, so it will be a vertical line. And that will have a slope is undefined. So if you still don't understand what I'm talking about, let's draw a little graph here. Here's our x, here's our y. We would have 1, 2, 3, 4, 5 on the negative side. So this is -5 for the x. And our line would go straight here. That would be what it is. X equals -5 no matter what y equals. So that tells us it is a vertical line. All right, if we look at example 4, and we have y is equal to 2. Well, y equals 2, if we look again at doing something like that graph, we have x and we have y. We have x, it's going to be y equals to 2 no matter what x is. So it's a horizontal line. And our slope is equal to 0. Alrighty. So now what we want to do is compare some slopes. We're going to compare the slope of a parallel, perpendicular, and neither lines. So let's go look over here. So slope-intercept form, that's an equation of the line that has a slope of m and y-intercept of 0, b. So here is your slope, the m, b is your y-intercept, so it's actually a point. Parallel lines are two distinct lines. They're parallel if and only if their slopes are equal or their slopes are both undefined. And then we have perpendicular lines. They intersect at a 90% or 90-degree angle. Slopes are negative reciprocals, and basically you're going to flip the fraction in the sign. So a vertical line has a slope that's undefined. A horizontal line is m equal to 0, and they are perpendicular to each other. So some perpendicular slope examples, if this was our slope, m equals to 5, our perpendicular slope, that's what that little symbol is, it's a mathematical way to do perpendicular, is equal to 1/5. So 5 over 1, flip the number, and it's now going to become negative. So if we have a slope of -3/4, our perpendicular slope, flip the number of the fraction, so 4/3, flip the sign from negative to positive. So let's go look at a couple of examples. So we are on to example 5. And we are given that y is equal to -3/7 x plus 4/7. And we are given that y is equal to -3/7 x plus 1/2. So the first thing we want to do to determine if it's parallel, perpendicular, or neither is figure out what our slope is. Remember, we're looking at y is equal to mx plus b, and what we care about is the m. So it's the number in front of our x, so m here is equal to -3/7 because it's in front of the x. The b does not matter, it's just the slope that we're worried about. Over here, we also have m is equal to -3/7. So because they are the same slope, they are parallel. They won't have the same intercept unless they're the exact same line. They'll just be near each other. All right, let's go do example 6. So we have y is equal to 1/3 x plus 2/3, and y is equal to -1/3 x plus 5/6. So again, we worry about what the slope is. So y equals mx plus b. Our m is equal to 1/3, Here our m is equal to negative 1/3. Now, they are not exactly the same, so they're not parallel, and they're not exactly the opposite, so they are not perpendicular, so these would be neither. They're kind of similar and kind of not. All right, let's look at example 7. So we have y is equal to 1/2 x minus 3/2, and y is equal to negative 2x plus 3. Our slope here is 1/2. Our slope here is negative 2. So think about that negative 2 being over 1. So this one was negative or positive, this one's negative, so the signs are flipped. And 1/2 flipped over would be 2 over 1. Because the number and the sign are both flipped, this makes this a perpendicular. So perpendicular lines, neither line, parallel line. Exactly the same, not exactly the same, not exactly the opposite, and then that flipped sign and number.